chemistry designed for integrated science students, right? So we are looking at the topic matter. Now the matter, we're going to look at atomic structures, electronic configurations, right? Atomic structures, electronic configurations. Okay, so we remember some of our first 20 elements, right? Hydrogen, helium, lithium, beryllium. I think most of us have acronyms in remembering those things, right? Okay, we can still use them. Now, when you look at the atom itself, what is in the atom? And relationship between the subatomic particles that we have and the concept of electronic configurations, right? How to write electronic configurations of the various elements. So I think in our part here, we don't go as far as the groups and periods in the periodic table, right? No, we don't do that for chemistry designed for non-science students, no. You'll be seeing that for chemistry designed for pure science students, right? Okay, now let's go. Atomic structure. So every atom has a tiny central part called nucleus. So every atom you see has a tiny central part called nucleus. And the protons and neutrons are in the nucleus. The protons and neutrons together are called nucleons. The protons are positively charged and the neutrons are neutral particles. Around this nucleus is a shell. The shell here, the first one will be called K shell. It accommodates electron. The next shell will be called L shell, M shell, and so on. Okay. So the subatomic particles and the electrons are found moving around the nucleus in shells. So we can illustrate the electrons using the bullet method or the cross method. Okay? Good. Now, these are the three subatomic particles. We have protons, neutrons, and electrons, right? So protons are positively charged, electrons are negatively charged, and neutrons are neutral particles. Those are the respective symbols and their masses. Now the electron mass is 1 over 1840 units. When you punch 1 over 1840 on the calculator, you're going to get 0.0000, which means 1, right? Good. So that's a fraction. The U means atomic mass units. Mass number is equal to atomic number plus neutron number. So when they ask you to find the mass number, that is the formula to use. Neutron number, that is what you use. Now, the atomic number is equal to the number of protons in the atom. If you have an atom with atomic number 17, chlorine, it means the number of protons in chlorine is also what? 17. In a neutral atom, the number of protons is equal to the number of what? Electrons. A neutral atom. So what is a neutral atom and what is not a neutral atom? Let's see something here. This is an atom called aluminium. It is neutral. The number of protons here is 13. Electron is also 13. This is something called aluminium cation. It is not neutral. Cations are formed when atoms loses electron. Aluminium has lost 3. That is why you see +3. The +3 does not mean it's a gain. Because in the atomic world, the atoms consume what we call electrons. So if you have more electrons, the richer you are, you'll be tagged negative, anion. If you lose the money, that's electron, you'll be tagged positive, okay? It's opposite to human life. So this aluminium you see has lost 3 electrons, right? So it's a cation. So the number of protons does not change. It's the same as the atomic number, okay? Now what will be the number of electrons here? It will be 10. Why? It has lost 3 electrons. Are you okay now? Let's try another one again. This is calcium 2 plus. Atomic number 2. This is the atomic number, right? This is calcium. The number of protons here is what? 20. Number of electrons is also what? Now let's go to calcium 2 plus. What's the number of protons here? The atomic number is equal to the number of protons. So what's the number of protons here? Again. Now what's the number of electrons here? Why? It has lost 2. Another one. Sulfur 2 minus 16. What's the number of proton here?
16.
Because proton is the same as atomic number. What's the number of electron here? What's the number of electron here? Why 18? Good. So when we say in a neutral atom, this is what we mean by neutral atom. Is this atom neutral? Is it neutral? No. Okay, so we're going to see some calculations on this right away. Now let's go to electronic configurations. We'll come back to this, okay? Okay. Now electronic configurations. It is the arrangement of electrons in an atom. So based on the octet and duplet rule, the maximum number of electrons that should stabilize a given atom should be 2 or 8. Right? So the first shell is called a K shell, it takes 2 electrons. The next shell is called an L shell, it takes 8 electrons. The next one after the L, the third one is called an M shell, it takes 16 electrons. But for stability reasons, it should take 8. Because the rule is what octet 8, duplet 2. Are you okay? Now the N shell takes 32. So those who do pure chemistry now can see 32 when you are going through the first transition methods, carbon to zinc, 21 to 30. But chemistry is designed for non-science students. We don't draw those configurations right? So we end our trouble on the KLM shell. Are you okay? Good. So let's try to draw the electronic configurations for the following. Let's go. Over here. I have helium. This is a chemical symbol for helium. The atomic numbers are written here. You see that? And the mass numbers are on top here. The mass number is 4. Are you okay? So anytime you see something here as an atomic number, what you see here is called what? The mass number. So that is what you see. Everybody break. So this is helium. This is 2. This is 4. So this is what? Mass number. And this is atomic what? Number. Are you okay? I've been asked to draw the electronic configuration for this. I start. Every atom has a tiny center part called nucleus. Within the nucleus are the protons and neutrons. Around the nucleus is a shell. So this is 2. It means it takes just 2 protons or 2 electrons, right? So I have 1, 2. Now this is called proton. In case they ask you to label, okay? This is called neutron. Now this is called electron. This is a shell called a K shell. Right? Good. Now when they ask you to write the electronic configuration, the first shell just took 2, so that is just 2. You will not be asked to write the groups and periods. You are not pure chemistry students. If not, the number of shells will give you the period, and the last valence electrons you see in the last atomic shell constitute the group. So helium is in period 2, group 2. But we're not doing that here, right? Okay. And the next one. Let me pick something we call calcium. The mass number is 40, but we don't need that in drawing. Are you okay? We use the number of protons or atomic number. Every atom has a tiny central part called nucleus. The protons and neutrons are here. So I draw my first shell. It is called a K shell. It takes a maximum of 2 electrons. The rules say 2, 8, 8, 8. Are you okay? As I said, it takes a maximum of 16, but for stability, that's 8. Okay? So 2, 8, 8. Based on the rule called the octet and duplet rule, not the 16th rule in the method. Now, the next shell is my L shell. It should take 8, right? Electrons can be represented with the bullet method or the cross method. 1, 2, 3, 4, 5, 6, 7, 8. The electrons are found revolving around the shell. They don't stand, okay? So I spread them. So this is 2, 8. That is 10. I'm left with what? 10 more. Or the rule is that it's 2, 8, 8, right? you close it, you don't add 9. 2, 8, so you close it, you do another shell, okay? So 1, 2, 3, 4, 5, 6, 7, 8. It's 10, 18. It's left with 2. I can't add it. The root is 2, 8, 8, 8. Are you okay? So I draw my next shell. 1, 2. Are you okay? So the first shell is called the K shell. This is called the L shell. And this is called the M shell. And this is called the N shell. Just that I was not fortunate in the N shell, I had to do 2. Are you okay? So it is 2, 8, 8, 8. You guys know when you say 2, 8, and you are left with 1, just want to add it to 8 with 9. The rule is the octet 8 and the duplet 2. So it's about 2 and 8. That's what. Good. Now, what is the electronic configuration here? We don't do groups and period. In case they ask you what is a group of cars, pure chemistry. The last number of valence electrons is 2. It is in group 2. What is the period for calcium? You count the number of shells. 1, 2, 3, 4. Period was 4. But nobody is asking this that, okay? There is a nucleus. Are you okay? Good. Now, electronic configuration. The first shell took 2, comma. The next shell took 8, comma. The next took 8, comma. And the next took 2. What is this? Electronic configuration. The arrangement of electrons in the shells of an atom. Can't you see this is how they were arranged? So that is it. Now, what about this magnesium? How will you draw Mg2+? Okay, over here. If I have to draw Mg2+, let's see what will go on here. Do you know Mg2+ is an anion, right? Or a cation, so to speak. It has lost 2 electrons, right? So will I be drawing using 12 electrons? I'll use 10. 10, that's all. So there's the first shell. There's a nucleus, right? Proton, there's a nucleus. Proton was neutron. First shell. 1, 2. Next. 1, 2, 3, 4, 5, 6, 7, 8. The last one. 1, 2. Only 10. Why? Because it has lost 2 electrons. But if it was to be magnesium neutral, I'll use how many electrons to draw? 12. Okay, so the EC here is 2. So there's 2, 8, 10. Okay, there's no last shell, right? Okay. So there's magnesium cation, right? It's magnesium neutral. It's magnesium neutral. You'll be guessing what? That last shell you see there, right? Okay. So that is it. Okay. I'll give you something to draw here. I just want let me part first and second. What's here? Let me part first and second. What about 10 and 4? Hurry up. Now draw for me sodium and argon.